How do we express measurements that are very large or very small numbers? We use scientific notation with the format m times 10 to the n power, and it's basically divided into two parts. The first part is the decimal part number that is between 1 and 10. And the second part is the exponential part number that is 10 to the n power. And here is an example of a scientific notation where you have the decimal part between 1 and 10 and the exponential part with the exponent of negative 10. So how would we make this decimal part between 1 and 10? There are two ways. Making the decimal part number smaller than the starting number will increase the exponent by the number of places moved. So that's what we're going to do first, okay? And I want to rewrite it in scientific notation. First of all, it doesn't have the exponential part, so we have to assume that it is multiplied by 10 to the 0, because 10 to the 0 is equal to 1. I know the decimal point is right here. To make 9,300 between 1 and 10, we have to move the decimal this way. 1, 2, 3. Okay? So that gives us 9.300 times 10 to the 0. Because the new number now it is smaller than the starting number, this will cause the exponent to increase. So let's say we are decreasing by 3 places, right? Minus 3. And to counteract with that, or to balance it out, we need to plus 3 places to the exponent. So what we have here is equal to 9.300 times 10 to the third. And this is all you have to do for in this situation. Now let's look at the second part where we do the opposite and make the decimal number larger than the starting number, which will decrease the exponent number in order to counteract the loss. Okay, I have a very small number 00127. Okay, it's a very small number and it doesn't have the exponential part, so we have to assume that it is multiplied by 10 to the 0, because anything to the 0 is equal to 1. So in order to make this between 1, we have to move the decimal again, but in this case this way, 1, 2, 3. Okay, 3 places. And what we have here is 1.27. So we are increasing the value by 3 decimal places, okay? So in order to balance it out, we have to decrease the exponent by 3 places. So what we do now is we're gonna, instead of adding 3 like this problem over here, we are going to subtract 3, okay? So in the end, what we have here is 1.27 times 10 to the negative third. And that will be our scientific notation. These two values are the same. These two values are the same. It's just another way of writing the same number. Let's try another example. In this case, we have 127. Okay, 127. And I want to convert this into scientific notation. Again, I have to assume that it is multiplied by 10 to the 0. And I know the decimal is going to be here. Because if it's not here, it would be a different values. So we have 1, 2. So we have 1.27. But that would decrease the original number by 2 places. So we minus 2. To balance that out, we increase the exponent by plus 2. So we have plus 2 right there. And our answer is 1.27 times 10 to the 2. Alright, the last time we covered how to determine the significant figures of a number. This time we are going to calculate with significant number. So that way, the accuracy of the measurement is not lost in the calculation. So here we have the first rule is for multiplication and divisions. When we multiply or divide, the answer keep the fewest significant figures. Here we have an examples. We have 5.02, that is 3 significant figures because when a number is larger than 1 and it has a decimal, all significant figure or significant. So it's 3. Same thing in this case. That decimal make all the digits significant. So we have 5. Here we have a number that's less than 1, 0.10. So this is your first non-zero, and all the following digit will be significant. So we have 2 sig fig. And when I plug this in the calculator, I will have the following number. Based on the rules, you are supposed to keep the fewest significant figures. In this case, your answer can only have 2 significant figures. How would I do that? You have to round. So in this case, I know this is your second significant figures. So by rounding, you are looking at the next number. If this next number is 5 or greater than, you will increase 5 by 1. If it is less than 5, this 5 stays the same, and you drop all the number after decimal. In this case, we have 45, and we don't keep any of this because this number doesn't have any values at all. So again, our answer is 45, and here we have 2 significant figures, 1, 2. Over here we divide, and we have 5.892 because of the decimal right there, and it's larger than 1. All digits are significant figures. And here you have the same thing. It's larger than 1 and it has a decimal, so all digits are significant figures. In this case we have 3. And I plug everything in the calculator, I have myself this number, 0.96590. But I can only keep the fewest significant figure, which is 3. So how would I make this into 3 significant figure? I would round it right here because this is where our third significant figure is going to be. So by rounding at the 5, I look at the next number, and this is a 9, which is going to make this 5 become a 6. So in this case, we have 0.966. We do not write 0 here because this 0 has no values to the number. Because 0.96600 is the same thing as 0.966. So this 0 cannot be placeholder. Now let's try another problem where I have a rules for addition and subtraction. When you're adding or subtracting with significant figure, you keep the fewest decimal places instead of significant figures. So we are concerning about the decimal places. So here we have 5.0. I'm going to use the same number up there, okay? And instead of multiplying, I'm going to add 89.665 plus 0.10. And I am going to plug into the calculator, and I'm going to get, what is it? 94.785. This is the exact values on my calculator. But we are keeping the fewest decimal places. In this case, we have 2 decimal places, okay? Right here we have 3 decimal places, okay? And here we have 2 decimal places. So what's the fewest decimal place we have? 2. Now how am I going to make this to have 2 decimal places? I'm going to round where the 2 decimal places are going to be. So 8. Here, this is where I'm going to round. So I'm going to look at the next number. Since it's a 5, that 8 is going to increase by 1. So it's going to become a 9. And I'm going to drop this 5. Now, this one right here has no values to it. So it's not going to be a placeholder 0. So in the end, we have 94.79. And this is our final answer with 2 decimal places. Let's do another problem. Here we have 10, okay, minus 5 minus 0.1 minus 0.102, okay. And we would have, from our calculator, 10 minus 5 minus 0.1 minus 0.102. That will give us 4.798. But based on the rules, we keep the fewest decimal place, which this one has 0 decimal places. So is this one have 0 decimal places. Here we have 1 decimal places. Here we have 3 decimal places. So how am I going to make my answer to have 0 decimal places? By rounding. So here I have my number, and this is where we stop before we enter the decimal. So to round at the 4, we look at the next number. This 7 is gonna make a 4 into a 5. So our answer is gonna be 5. And there you go. Alright, let's talk about rounding. How do we round numbers to keep the correct significant figures? So, there are two basic rules. One is that if a number is 5 or greater than, we would increase the previous digit by 1 and replace the remaining digit with 0 for placeholder if required. Okay? So, for instance, we have 125,379. That's a large number, right? So, we are going to round to have two significant figures. Where would I round to have two significant figures? This is a first significant number. This is a second significant number. So this is where we're going to round. So when we round, we're going to look at the next number to determine the effects of this number. So 5 is going to make a 2 into a 3. So here we have 1, 3, and we're going to replace all of this with 0. And they call placeholder. Why is that? Because if I were to remove this 0, we will only have 13. So this 0 represents values, right? So that's why we're adding 0 there. Now I'm going to try another number where I'm going to round to have two significant figures where we don't write 0. So here we have 1.2950. Okay? So when I round this to have two significant figures, again, two significant figures, it's going to be right here as well. I'm going to look at the number next to that 2, and the 9 is going to make the 2 into a 3. But our answer is going to be 1.3 only. Why is that? Because if I were to replace this with 0, it wouldn't have any values, right? Because 1.3000 is the same thing as 1.3, so we don't care about the 0. Now what if we have a number that's less, what if the next number is less than 5? So what do? What if the number is less than 5? When the number is less than 5, the previous number stays the same and replace the remaining digit with 0 for placeholder if required. So in this case, we have 1253.79, okay? Because we want to have three significant figures, I'm going to round as this is the first one, second one, the third one is at the 5. So we're going to round right here. So when I'm going to round 5, I'm going to look at the number next to 5, which is 3. That 3 is going to make the 5 stay the same. So what we have here is 125, and that 3 is being replaced by a placeholder of 0. But the 7 and the 9 are not. Because if I were to remove the 3 and do not write anything, I would have 125. Instead of 1,000. So that's why we need to put the placeholder here. Because 1250.00 is the same thing as 1250. Because this one has no additional values to the number. Let's try another one. Here I have 127.592. How about that? And the first one I'm going to do is I'm going to change to have two significant figures. So I'm going to put 2SF, okay? And therefore, we are going to rewrite this number 127.592. And to have two significant figures, I'm going to round here because this is one significant, two significant. And I'm going to look at the next number after the 2. That 7 is going to make that 2 into a 3. So what we have here is 130. Why do I need the 0 there? Because it tells you values. I don't need the 0 here because it doesn't have any values to it. Now let's try another one where I'm going to make it's going to have 4 significant figures. Okay, ready? So what we have here is the 4th significant figure, right? So we have 127.592, and this is the 4th one. So I'm going to look at the next one. That 9 is going to make a 5 into a 6. So what we have here is 127.6. Do we need to put the 0 here? No, because 127.60 is the same as this. So we don't look at this one.